Hello, everyone. So I just wanted to go over a few things that the textbook doesn't cover very well, but you're going to see in your homework and on your test. And that has to do with calculating the uncertainty from an equation. So just to recap here, we're going to use the lowercase Greek symbol delta, and that's over here for our uncertainty symbol. So for example, if we measure the length of something to be 3.2 meters plus or minus zero point 0.3 meters, we would say that the length x is the 3.2 meters, that's this first term, and then the uncertainty in that value, the uncertainty in x, delta x, is equal to 0.3 meters, that's this plus or minus 0.3 meters. So that's how we take this measurement and turn it into these equation forms. So uncertainty is also commonly called error. You may have heard it called that, but we're going to use the term uncertainty in this class, and so does the textbook. So we want to use this in an equation. So let's say we want to know the area of a table. We measure its length to be 1.50 plus or minus 0.05 meters, and its width to be 1.15 meters plus or minus 0.05 meters. Now, we can get the area from this. That's easy. We can just do area's length times width. And following our uncertainty rules, we get three significant figures. So we get 1.73 meters squared for the area. But we want to know is what is the uncertainty in that area? This is this number plus or minus what? How accurate is that going to be? So let's look over here at this figure. So here is the width and here's the length. You see this green box? Well, this is that length times width that we just measured. But the thing is, this width length actually could be a little bit bigger, right? It could be plus or minus this delta width number, this 0.05. So it could be a little bit bigger or it could be a little bit smaller. And that would change the area that we calculate, doesn't it? So if it was bigger, if both of them were bigger, then we have this big area. And if both of them were as small as they could be, we'd have this smaller area. So you see we have this is our area, and then plus is this white portion over here, and then plus or minus this other portion here. But how do we get what those actual values are going to be? Well, what we do is we just calculate, well, what's the biggest the area that it could be, the whole thing, and then we subtract the smallest the area that could be, and that would give us this whole region here. And then we divide that whole region by 2 to cut it in half. And that's what's going to tell us what the uncertainty in our area is going to be. So let's do that calculation together. So the biggest the area could be is the same as length times width. Well, the length could be, add the uncertainty in lengths. This is the biggest length, right? The biggest it could be. We multiply that by the biggest the width could be. So W plus delta W gives us the biggest the width could be. And following our significant figure rules, we get 1.86 meters squared for the biggest that the area could be. And then we calculate what the smallest the area could be. Well, L minus delta L gives us this length here. We multiply that by width minus the uncertainty in width gives us here. So we multiply those together, and that gives us this little box here. And that gives us our smallest that the area could be. And so what we can do is to calculate the uncertainty in the area, like I mentioned before, is we take the biggest minus the smallest and divide by 2. So that's what we're going to do. So the biggest the area, that's the 1.86, minus the smallest, 1.60, and we divide that by 2, gives us our uncertainty of 0.13 meters squared. And we got these significant figures by following our rules. So the area is the 1.73 plus or minus, 0.13 meters squared. And that is how we calculate the uncertainty in an equation. Now that was for area. You can use this type of principle to calculate the uncertainty in any calculated value. It could be velocity, acceleration, a whole number of different things. So the uncertainty in a calculated value is just 1/2 the biggest the value it could be minus the smallest the value it could be. So we want to put values into our equation to calculate the largest that x could be, and we plug it in there. And we put values in our equation to calculate the smallest that x could be, and we put it in there. And then we plug it into this equation in order to calculate what the uncertainty in x is going to be. All right, hope that helps.